this screenshot of who you're going to have interventions from in the next half an hour. Okay, we started the discussion thanks also to Kuba and Ignacio that brought in the point on how ScienceMesh and CS3 can do something for EOSC, and I think this session was sort of the beginning, and it's entitled Scientific Disciplines Embracing No Border Research Environment Thanks to ScienceMesh. And what's nice in this next half an hour is that we wanted to show that you can see either infrastructures or projects that have been funded under the science clusters and other projects, in this case, the CS3 Mesh for EOSC project, how they've faced some challenges and how they're addressing them by working on federation and interdisciplinary activities together. And the objective is then to pull out this very easy concept and story that the ultimate aim is to say, this is going to go into EOSC, by the way, isn't this wonderful? And we deliver some EOSC in practice stories that are easy to understand. So this is very close to my heart because it's something we cited back in 2017-18 when we put together the first high-level expert group paper called EOSC in Practice. And so this seems to be taking place, and what we said before is there's an adopter program going out in January, launched by the EOSC Future Project. So please stay tuned to that. So we'd like to respond to that. And what we'd love to see is some of the interventions you're going to hear now from our esteemed panel will then get turned into these use stories, EOSC in practice stories that we've mentioned before. Okay, so without further ado, I'm going to pass the floor quickly to Xavier, who's our first speaker. And Xavier, you all have slides, I understand. So Xavier is an applied physicist staff member at CERN. He works on the ESCAPE DIOS, the data infrastructure for open science. And he's also coordinating the WLCG project on storage consolidation, data lakes and data access for the future HLLHC. So I'm trying to pull out from your profile the part where there's the interdisciplinary part with other projects. So over to you, Xavier. Thank you.
Thanks a lot, Silvana, and thanks a lot, Rita, for sharing. So I think we can skip to the second slide. I have less than 30, so I can make it in less than 30 minutes. In fact, it will be quite quick. So in a nutshell,
let
me introduce probably in 1 minute what ESCAPE is doing, which are the links with the ScienceMesh and the CS3 Mesh for EOSC, and some proposal to basically join path and go forward with some proof of concept. So ESCAPE, in a very kind of big framework, is trying to set up together a data infrastructure, a storage infrastructure, together with data management tools. This means to provide experiments, a way to do data management, to do data recording, put policies, replication rules, quotas, ACLs, at the service of the experiment. It is something that we in the LHC, it is done since many years, but there are more and more experiments which are reaching a scale where when to manage big volumes of data, big number of files is getting complex. So that's why experiments from astrophysics, cosmology, gravitational wave are adopting this infrastructure. We are prototyping this infrastructure to basically put at the service these tools, data management tools, data movement tools. Now, this ESCAPE is covering a fraction of this kind of big data or heavy-duty life cycles for the experiments, but also is opening the door to stretch it and put it at the fingertips of the researchers, students, outreach activities, open science, etc. That's why the data lake is being integrated with analysis platforms and notebooks. So you can have your notebook and then have a window through this big data, which is basically the many petabytes that are injected by the experiment. So the data lake is evolving through the collaboration with the scientists to explore new feasibilities and new handles in terms of metadata classification, data browsability, etc. So that's why there are possibilities, and in fact, there is the need to extend the scientific data lake to accommodate to very, I would say, very complicated workflows in data, to very simple access and use, like cloud storage. You put data there, it get basically in the background it get fair, so it get replicated, consolidated, and then it's easy to access for the user. So probably, Rita, you can move to the second slide, which is basically what is the meat of this intervention. So what is the goal? What is the goal and possible collaboration with ScienceMesh? And I wrote it here very raw, I think, is to provide a data management and access facilitating service, something that can be exported in the use portal or the experiments can deploy and can use, which basically means an integrated data management and data access compound layer, which means software. You all know the Rusho, the data management, FTS for data movement, a common AAI, etc. So this will be the main goal, to have a service in EOS, imagine for sciences that have more modest needs, to basically make use of this service or the experiments inheriting this. So why this is a good idea, we think it's a good idea, is to bridge this diverse scientific data, no matter if it's a big experiment, if it's a small experiment, with these activities which are basically guided by the researchers, students, addressing outreach activities, open science initiatives, etc. So on one side is a data lake, which are doing the heavy lifting for the data which is managed by the experiment, data injection, replication, this I mentioned. This is what is good data lake, but can be stretched. And then also from the other side, the ScienceMesh can be stretched, so the two things are merged together, because the ScienceMesh can put together this data at the service of the population. I mean, this sharing with the different infrastructure, put it in a window in the notebooks, integrated with sync and share facilities, so the scientists can interact with the data, doing their analysis and doing scientific collaboration in documents, etc., plot, etc., etc., and also interacting with the home directories. This is no question. This could be a good way forward. Also interacting with the heterogeneous computing resources. So, what to do in this perspective? I think what we need to do is to provide some hints and basically try to build up a proof of concept to put forward these ideas. So, and offer the possibility to really connect the ScienceMesh with a data lake. We need really to prove this and to show it, and how we can do this. I think enabling the ScienceMesh activities in the Escape Data Lake is basically three things that we need to address first. The first one is to integrate the data management system of the data lake, which handles all of the big data of the experiments. This is Rusho. And the FTS, which means able to move data from site to site inside the data lake and also in the ScienceMesh nodes. This is something that is worked on in this direction. I think the proof of concept could be quite easy to sort out. The second thing, which is fundamental, is to have a transversal authentication mechanism, probably based in the Escape AIM service, and ensure this token-based authentication is honored on the full stack of what I call the data chain, from the experiment getting data to the last consumer on the other end. And to finalize, we need a catalyzer. We need some support in trying to set up this proof of concept. And in my mind, and one experiment that could be interesting to start with is LOFAR. LOFAR is very active in Escape. They participated in the data challenge that we did in Escape in these last 2 years. They proved they can run workloads, they certified data access from different resources. And also LOFAR is active in ScienceMesh. So it sounds like a reasonable proof of concept to start with. So, and from, I believe my contribution with this question mark. What is your vision on that? I was quick. I hope I was clear.
Sure, Xavier. In fact, I put in the chat here, something we discussed was to consider ScienceMesh as a resource within EOS, right? So that is it similar to what yours? Well, that would be my answer to your question, right? In going forward. So to taking it from Escape and then having it as the final destination.
That's correct, Silvana. So I can imagine a service in EOS which basically obscure or hides all of this complexity for the users. So you offer the service. Yep.
So I got cut out. Sorry, Xavier. What was your reply? I don't know if I got cut out.
Yes, that I agree. I think that the idea is to have, imagine you can have a service in EOS which hides all the complexity for user or for experiments. So you can use this. So you put data there, you put this behind, and then you basically give access to them and share this data.
Ignacio's still on, actually. And so with that, let's prepare also for our next speaker, from Mari Klimov, from SCHOCK and University of Tampere. But I want to go back a second so we can move, and then I'll go back to Mari. Ignacio's on, and I don't want to push anything on Ignacio now, but I saw in the ESPRI conference that's been happening as well, there was a comment from, I think it might have been Francisca de Jong, who said, yeah, we love how EduRoam works, that no one, actually understands the technicalities behind it, but it just works and it's simple. And, we need to obviously consider these same features for what wants to happen then eventually in EOSC, okay? Feel free to put in anything in the chat here while we move on. So thank you very much, Xavier. That was wonderful and to the point, and you described the challenge, described what we could focus on what the end goal could be. Mari, hello, how are you doing? Mari is a development manager at the Finnish Social Science Data Archive, Tampere University, and she's also a member of the EOSC Association Task Force on Fair Metrics and Data Quality, and you work on different projects in EOSC. So over to you, Mari, thank you.
Thank you, Silvana, for the introduction and the invitation. So I'm here as part of my work in SCHOCK on trust and repository certification. So that's basically my viewpoint today. And SCHOCK is, of course, much more. I won't go into details. There's the website. You can go there. So next slide, please. So my starting point here is that different kind of repositories and services are key parts of a fair data ecosystem. And in this ecosystem, trust between different actors is essential. So that's the main thing. And then this trustworthiness can be determined by comparing evidence to requirements using an assessment process. So this is the very general level thinking. In SCHOCK trust work, we have supported selected social science humanities repositories in their journey towards core trust seal certification. And if you don't know it, it's the core requirements for being a trustworthy digital repository. And it's for repositories that have a mission to preserve data for the long term. So that's the main thing. So there are several lessons we've learned, several challenges. So for example, there's a huge variety of repositories. There are generalist repositories, specialist services, technical service providers, and anything in between. And all of these repositories exist for a reason. So they all have an important role in the whole research ecosystem. But they have different missions and goals, different organizational settings, and very complex organization settings, different maturity levels. I think one of the challenges is that sharing of responsibilities is in many cases very unclear. There might be some sort of blind trust between the actors, but that's actually a risk. And the usual story is that services are working well enough for now, but lack of governance, for example, and lack of metadata and documentation make them vulnerable. And as a result, the data is at risk. And I think we can all agree that digital data is an asset that needs to be managed during the whole data lifecycle. So I mean, next slide, please. So that was a very general set of challenges. And I think I've learned this what I think is a nice picture from Hervé Loos and Ilona von Stein's paper. And it describes the FAIR ecosystem components. It's based on the Turning FAIR into Reality report. And I'm sure there are other visions as well, but this is a nice way and shows the complexity of the ecosystem, even though it's a simplified picture. So we need these fair enabling services, repositories, registries, and people and skills to ensure that the research data objects and other digital objects remain fair and usable also over time. So I think services and ScienceMesh, for example, is an important piece of this puzzle. It enables data management and good and fair data management in an important stage of a data lifecycle. So and when it comes to, for example, repositories and with long-term mission, for example, they can be using the same service. Well, for example, ScienceMesh, I think, to ingest data that's been produced on campus, for example. And if these repositories that are using ScienceMesh as part of the services, if these repositories can wish to get certified, they will need to provide evidence to back up their statements. And since they are all using the same service, they would benefit from common shared evidence provided by ScienceMesh, for example. And so even if ScienceMesh, because it doesn't have the long-term preservation mission, it's not eligible for Transversal, it's a vital part of the ecosystem, and these all services can work together. I would also I just want to conclude by saying that the world is not ready. So as I mentioned, Transversal certification is not fit for all. And while ScienceMesh, for example, can help repositories that have the long-term preservation mission in achieving Transversal certification, I think there's a need for different certification frameworks and evaluation of existing frameworks. And this goes for TDR, certification as well as to verification. So, and it's a developing scheme. Thank you.
Thank you very much, Mari. That was also to the point. But I think, would you agree also that thanks to sort of initiatives like these ones that we're hearing today, is sort of pushing the boat out to try and make sure that some collaborations can take place? You know, after sort of, yeah, I'll pass that's just a quick question to you, Mari.
Yes, yes, and we need to see the bigger picture and how the services and actors can complement each other and work together. And of course, there will be some competition as well, but generally speaking, it's more about collaboration.
Exactly, and as we were mentioning before, you know, well, trying to pull out an Austin practice story from this would also be extremely valuable. SCHOCK is coming up to its final phases of one of the science clusters. It was one of the ones that began before the others, actually. It ends at the end of, no, it ends in April, actually. Yes. So it would be lovely to have as a, you know, an asset going forward, this type of result of where the collaboration goes forward. And remember, ScienceMesh isn't part of an EU project. Okay, so the whole sustainability action is much more reinforced there. Moving on, thank you very much, Mari. We're moving now to Francois Perrin, who's representing PANOSH and the European Synchrotron. He's in charge of the IT infrastructure, the ESRF, and he, inside PANOSH, he animates the work package to facilitate the integration of the RI services within EOS, so it's perfect for this setting and this particular session. Over to you, Jean-Francois. Thank you very much.
Yeah, thank you. Maybe we can stop at the second slide, just a second. So just to present PANOSH very briefly, this is 6 data producers, so research infrastructures in the field of neutron or photon beams. That's all. We have also EGI, and we are working very closely with another project called Expanse, which is for the same community, user community. Next, please. So just to present the community, this is a relatively large community. in terms of users coming every year on the beamlines for experiment, getting the data, but also in terms of scientific field, from biology to even high energy physics. This is very large. We have academics, which represent more or less 80% of the population of users, but also industrial users. And we produce data, a lot of data. Next, please. The project PANOS can expand, have strongly focused on making the data fair. So we have a framework for the data policy that we are all implementing. We have developed e-learning platform for the users. In terms of data management, all the data are presented in data catalog. They are accessible through APIs. The data, we mint DOIs for the data, and we are working on DMP for the users. Next, please. But for today, maybe it's more interesting to talk about the service we have developed for the users inside PANOS. So there is basically two types of services. They focused on data analysis mainly. We have the notebooks like many others, and we have also a solution called Visa, which is a remote desktop, which provide for the users the software, the hardware, the resources, GPUs, CPUs, and a direct access to the data to avoid the transfer of raw data by the users. Next, please. And the main challenges that are still on the table were probably around the data transfer. So we had 3 use cases for data transfer. One, which is a very typical from the community, is users having performed an experiment want to get the data back home. For this, we have put in place 2 solutions. One for the academic, or mostly used for the academic, which is Globus, and another one which is more, which is requested by the industrial quite often, which is IBM Aspera. The second use case was how a relatively small data producer, an RI, could archive the data, and we are working with STFC for that, using their ecosystem. And this is a clone that has been selected, and that is in production now and working quite fine. The third one, it's a bit more, it's a bit different. This is how do we transfer the data for users when they want to use a compute facility which is not on the RI. We can move to the next slide to explain a little bit more. Yes, again, there's an animation which I shouldn't have put inside. If you can go for it. No? Yes, perfect, thanks. Basically what you see in the slide is that all these RIs have their own repository or own archive. When they provide data analysis services locally, they will use NFS or local protocol that works quite well on the LAN, but are not done for internet. And here on the right, you have another service provided by some organization which are not necessarily part of the community. In that case, it's AGI. And the user coming for using this service, how could he transfer the data transparently? And how could he just ask to the data to be transferred? So for this one, we are exploring currently at the moment AGI Data Hub, which is a one data solution, but other solution could probably fit the needs. And this is something that we can explore more. Next slide, please. And the last one is the software provisioning. This is typically for Visa or HPC solution or any compute solution. And when it's not local, when this is, if you take the example of ESRF, we have some specific software to analyze the raw data produced by our instruments. Users will need this software and don't want probably to install them. They want to have them installed wherever they go for analyzing the data. So here we pick up CVMFS, and I see that in Mesh, CS3 Mesh, this is also something common. We are at the beginning of we are, I would say, evaluating because it's not deployed everywhere, but this is a solid candidate. And this is what we are working on at the moment. And maybe there is room for cooperation, common work with CS3 Mesh. That's all. Thanks.
Okay. Thank you, Jean-Francois. In fact, my question to you would be, so which is the connection with IOSC? It would be indeed the part on CVMFS. So can we touch base on this in the coming weeks or months? I don't know when you're thinking about this, the whole sort of program around the synergies. And once you have some updates, then you can inform us. Would that be okay?
Yes, not very clear, but yes, we are working on it. We are deploying it.
Right. Oh, so well, no, you said it was something you were perhaps considering. So that was
it's an evaluation, but we are more or less at the end of the evaluation. There is not much other solutions for facing this problem. But if you have expert and we have question about CVMFS in terms of organization, when you mixed different organization of the repositories, when there is different organization publishing software, things like that. So we would benefit from experience from others, clearly.
Okay, that's clear. Okay, I appreciate the answer. Thank you for your timely presentation too. Jiming, you're up next. Then, if you want to share your slides. He's currently a senior researcher in the group of System and Network Engineering at the University of Amsterdam. And he works on different EU projects. And at the moment, the specific one is working around data for science theme in the EU 2020 Environmental Science Cluster Project ENVI Fair.
Yeah. Obviously, that was my CV probably some years earlier. But I can introduce myself. Thank you very much. Sorry for keeping you here because I have less flexibility for tomorrow afternoon.
Don't worry.
So I'm here. Yeah, I'm here to represent every fair project to explain you, the possible or potential synergies we can have with these CS3 mesh for years. So actually, I myself have been working for the ENVI community for more than 10 years, ever since the first cluster project starts. There was the 2011 called ENVI, and then we had ENVI Plus, and that was 4 years. And then now it's the third project, it's called ENVI Fair. So basically, along all these different projects, so the key mission is, we want to interact with different research infrastructures in the environmental and earth sciences and work with them to understand their, data management challenges from the very beginning when they collect the data and then try to understand, the diversities for, of the standards and the diversity of the, the protocols, so that eventually we can tackle their common problems, common challenges, and to help them be more interoperable. Yeah, so that was the mission. And of course, each stage we tackle this on the, different aspects. In the very beginning, we tackled this, try to build a common language, made a reference model, and then we look at, different small pieces, make lots of different tools to manage the data. So now in the third phase, ENVI Fair, we try to take one step further. Can we really help them to move all the different digital assets or research assets from data software, make them really fair? Yeah. So what you can see from these diagrams, so all the infrastructures we are interacting with is really a big set. It's more than 20, and they're across 4 different domains. So currently the main activities we're working on, making things fair. Of course, this is the most important things. And we have, lots of different task forces looking at different aspects from the PIDs, from the, the AI, from the, metadata standards, from, the policies, et cetera, et cetera. By working with these task forces, we try to build, recommend common standards, and then build a couple of, services based on what the individual research infrastructures are building. And then we want to deliver a kind of concept, which is called ENVI Hub. Yeah, through this hub, basically the end users from maybe, from the EOS context or from, the individual communities from the research infrastructure, they can find the resources from different infrastructures from a single point. Basically, maybe we can move to the next slide, please. From the ENVI Hub, we can, enable the users discover the things, discover the online resources, digital assets, and then try to use these platforms to share their engineering practices, technologies. That's basically the first pillar we call knowledge base, and including a search engine, and more for human users. And the second pillar is called catalog. So the catalog is kind of, service. We aggregate different metadata catalogs from individual research infrastructures. We ingest, the research assets from there and put them to, hub level catalogs. And that catalog provides machine-to-machine interface to enable automated workflows. If you want to access, the data sets, if you want to access software surfaces, you could get them and couple them to the workflow automation pipelines. And this will also be a kind of point, we're of course still under discussion, to make this as a potential point for the EOSC in future to ingest, make this as part of the EOSC catalog. And then, besides these two, there is a third, pillar that is, eventually will be the virtual research environment. But for the moment, we just call these every use cases. And we're going to look for, different kind of, demonstrators by using the research assets from different eyes, and by showing how these assets can be coupled together as a workflow. So by using, the resource from individual research infrastructure, but more importantly, how to do this across them with support from e-infrastructures and even with, the public cloud. So the possible synergies I can think of, first, let's say, soon after we have the metadata catalog, the importance we're going to support is to make all these assets, accessible. Not only retrieving the metadata, of course, you want to access content, but how to enable the user or workflows, access data from multiple sources, and then share across different workflow processes or users. So that would be, the first, let's say, a kind of at a point we're going to, need a very nice solutions. The typical challenges I think we're going to face is, of course, the trustworthiness is one important thing, but the trust organizations, the repository is just one part. We also have to think about how to enable trust among, these individual researchers, and how can we, allow users to define their own, trust share policies. That would be something, we have to think about, because that is very important, for the virtual research environment, for certain communities. If you want, also make your intermediate data products, not just the data products you retrieve it from the original source, isn't it? So you have to enable that part. And the second is, we think, the could be the possible, let's say, these synergy would be interoperable infrastructure automation. Well, access to the data is just the beginning of the scientific stories, and how to, move things around, and then how to automate, these on-demand services for computing, and also for storage, and, or during the workflow life cycle. Of course, at the end, you're going to put it somewhere for, to publish. But all the things, all the dynamic resources in the middle, how can we get them from, from where? What will be the service level agreement? How can we automate it? How can we, assure the trustworthiness? And can we also do this, with, a kind of interoperable support for these public clouds like Amazon, Azure, and those things. Of course, we can use this for, developing data service and operating them like DevOps, testing them, and for running, workflows. And the last is the virtual research environment. We have been actually looking at the Jupyter environment, just like many previous speakers talking about. In Every, we also look at it. My team actually will we specifically look at how can we couple these different VRE functionalities, make them as extensions on the Jupyter environment, so that user can automate cloud services and make the sharing, even access really the advanced data sharing services like a peer-to-peer file systems or even blockchain, those kind of things, seamless from the Jupyter environment. So that would also be something we are looking at. Of course, I think lots of functions using the service from the service ScienceMesh probably already have some mature solutions, and how to couple this with the future Jupyter VREs. That would be something I think in the rest of the Every project we can also look at. And those are just the points I enumerated based on the access part, which more close for this panel. Of course, within Every fair, there are many other technical issues. Majority effort now still we're spending on the let's say the metadata semantics ontology types of topics. Yeah. So okay, I'm going to stop here. This is just a quick summary of Every fair and the data challenges, etc.
Thanks, Jimmy. We're wrapping up the session, but we have our wonderful last speaker, Mark Vandersander, while you prepare that. Jimmy, what I'd like maybe to see, though, is maybe that for the next step that we try and pursue this, as I said also to Francois, as a concrete collaboration. So we really need to push this boat out further and say, right, we've tried this, we think ScienceMesh could be the answer to, I'm not trying to sell ScienceMesh, but when we talk about synergies, we want to give back to the EC the assets that are going to work, and we're showing nice collaborations, and we can do it. If we can, this is what we should be doing in the next phase. Thank you very much, Jiming. Wrapping up, Mark van der Sanden. Thank you, Mark, for your patience. See, we are managing it, and we still have 41 participants online. That's great. Mark is working as a research service specialist within the data preservation services team at SURF, and you're involved in many EOSC-related projects. In fact, seen your face in many things, and you're always a great contributor. And you're also a member of the EOSC Architecture Working Group, and you're on the EOSC, and currently you're working on the TF on interoperability between data and services, correct? So over to you, Mark. Thank you very much.
Yes, thank you. I see that I'm already sitting in the dark because becoming late. Yeah, on this slide, I try to explain a little bit where we see the challenges. EUDAT is an European organization providing a collaborative data infrastructure, providing different kinds of components to serve communities to implement better data management practices. And one of the challenges which we see is if you look at the vision, data is shared and preserved across borders and disciplines. It is very similar as, for example, what EOSC is also having as the aim to provide. But there you also have one of the biggest challenges, and that is mainly across borders and disciplines. And if you look at the diagrams below, there are many different communities, but also there are many different infrastructures providing services, collaborating with those communities. And very often they are developing solutions which are working very much in one community, but not always work in another community. And one of the things is what we try to do with EUDAT is to provide common building blocks which can be used across different communities, but also have them as an interoperability building blocks. So therefore, what I currently see as one of the biggest challenges is technical interoperability, because if you look at all the different RIs, but also the infrastructures, they still develop the services and the solutions more in silos, bespoke solutions. And I think we try to come to more general solutions which are interoperable across the different infrastructures in itself. Next to technical interoperability, you have also the access to resources, and that is data and services. And that is access to the physical services and resources. For example, if you look at the AI type of challenges which we still have, but it is also not only technical, it is also policy-wise. So if you have technical, you are allowed or get access to a service, does not mean that you are allowed to get the service because you do not have the rights to get to those services. And that is more a soft part of interoperability. But that should also be overcome, and then not only for between a research infrastructure and a provider or a community, but more in general. What kind of agreements can you have more in general? For this, I also put in the logo of EOSC, and I think that is one of the drivers to see how you can overcome. And if you look at for the EOSC Future project. There we have a big collaboration with many of the infrastructures, but also of the different science clusters. And I think that can be a platform where you come together to see, okay, how can you overcome those challenges, but how can you come to consensus to which kind of standards to use, but also, for example, how do you develop policy so that you can get access to the services and resources which are across and provided by the different infrastructures and RIs. If you go to the next slide. If you look at this, B2Drop is our EUDAT Sync and Share service, which is based on Nextcloud. And I think therefore there is already automatically synergies with the CS3 community and the ScienceMesh to see, okay, how can you connect those together? But as I think is also shown already in the previous presentations, the ScienceMesh is not only about sync and share. It is a platform to connect, but you have not much more services which are of interest of the communities, which they want to use. They want to use for data analysis, but also for assigning persistent identifiers or make data discovery or publish data. So therefore, I think what we should look at to see, okay, what are common approaches on the interoperability? How do you connect to computing and analysis services? And I think there's already some initiatives within the ScienceMesh where they are working at to see how you can do this from a sync and share service, but maybe we have to expand this to see how you want to do this for other kind of data platforms. To look at common publishing workflows, because if you have the data available, you do the computing and analysis, but you want to also make the data available and share this with others in a different way as publications, but also make them discoverable. So also there you can see, okay, how can you make this easy workable in different platforms so that you can common tools, common plugins, type of interfaces to make this available so that you can, for example, publish data in Zenodo, which is Invenio based, but also, for example, B2Share. Luckily, this is also Invenio based, but you have many different repository platforms. And if you have tools so that you can work with those different repository platforms, then I think it will already help many of the researchers to make the data available. Federated AI is still one of the biggest challenges. How do you get access across different services, but also if you have access in a service, how can you access other services from that service? And that there also are initiatives already also within the future to try to solve, but also come to an EOSC AI federation where you can connect those AIs to each other. Then making services and resources available across infrastructure, I think, because you have those different infrastructures, and it would be very helpful if you can connect services across the infrastructures, but then also have to look at the technical interoperability to be able to do this, but also on the policy side that you are allowed to do this. And collaborate on common use cases, because most of the work, I think, is very important to go further to have a common use case, because that is also an incentive to collaborate and try to solve things. And I think there are already good matches between the different infrastructures, but also, for example, within CS3 mesh for EOSC, but also within EOSC Future to see where you can bridge on common use cases to start working. Yes, this is
nice, Mark. Thanks. I think that was a good concluding point as well. That it clearly draws in to the opening of EOSC Future that you're also involved in, and I think I'd like to think on the basis of this session also it's opening different avenues to push the common use cases together in the next weeks and months. We're done, and I'm going to pass the closing remarks to Kuba. Thank you very much to all panelists. Thank you for your perseverance and staying on, and thank you very much. We hope to see lots of EOSC practice stories coming out of here. Over to you, Kuba. Thank you.
Thank you, Silvana. Thanks a lot also for managing this session in these circumstances. And yes, I think what we have seen is very promising, because I think in many of those presentations I could identify elements which are very clearly an opportunity for synergy, either at the level of the infrastructure, for example, like it was presented on the last presentation, to essentially have, for example, EU.data infrastructure interoperable with ScienceMesh, or at the level of actual use cases in the research infrastructures and the new research communities. exploiting some common tools and approaches, maybe through Jupyter notebooks, maybe through software distribution, through access to the digital repositories, and some, perhaps not only at the level of integrating technically these components, but also at the level of maybe sharing some practices for the, the best practices for the researchers on how to use these different tools and these different infrastructures. So thank you very much to all the speakers as well. And I think we definitely need to follow up on this. Perhaps, Silvana, we can discuss how we can follow up.
Yeah, I think also, sorry to interrupt, if this adopter program comes out that I've understood, and I'll find out more about this, as soon as this is out and there's the application form, I certainly think that a takeaway from this session needs to be that a set of applications are submitted. And that would be, a perfect takeaway from these first collaboration discussions.
Yeah, okay. All right. So I think this brings us, unless anybody would like to add anything, anybody from the audience would like to share some thoughts with us on what you have just heard. I think it's an opportunity for EOSC, but I think it's also an opportunity for ScienceMesh, and it's an opportunity for many of those infrastructures that you have presented. And I think our job is essentially to try to come up with a win-win situation where we can really connect these dots and everybody can essentially benefit from these synergies. That would be my take on this.
Yeah, also thinks that ScienceMesh, having heard these presentations, that ScienceMesh can form as the glue between a number of these projects.
Yeah, in particular, in ScienceMesh, it's already a multidisciplinary infrastructure because essentially each node, existing node in ScienceMesh currently has access to another discipline, another user community, and in this way we are building that multidisciplinary aspect of the infrastructure as well. So essentially, the node operators are the way ScienceMesh is conceived is that the node operators, so the nodes in the mesh, they're already very closely working with some particular either local communities or or are also providing services in some infrastructures. And for example, a very good example of that is Escape, where we have found many interesting synergies because the same site is part of ScienceMesh, it's also part of Escape, and it's part of particular communities such as LOFAR, for example. You couldn't get a better match.
And part of UDET and part of
also part of
Future and
yeah. Another interesting aspect in general is currently all the nodes in the mesh, essentially they have their own local user base, so people that have access through that local node. But probably what is on the radar of the European community, I imagine, is also to cater for people that do not have institutional access to services. So and I think this aspect is not yet fully covered in the ScienceMesh.
I think just to comment on this, I think, for example, EUDAT can provide some of those because many of the services which we provide are also public, and you can register on those services. Therefore, you can get access. But also, if you then connect to the ScienceMesh, then you can also already collaborate with people which have access to other kind of services and different nodes.
That could be one possibility, for example. Yes, that's a very good example. So I think we have really a very rich.
Sorry,
yeah.
Giuseppe has written something in the chat.
Sorry, yeah.
Yeah, which is nice, and it's a good point to sort of chat more on this topic tomorrow at Gather Town. I don't know, maybe we should also exploit the fact that we should maybe feed back also to the EOSC Association too, and we have Ignacio on the call too. That can be a very good linkage there. We have other contacts clearly. There's Bob and there's Sarah too. But it would be, I don't know if we need to do another maybe coordinated gathering in a couple of months' time, if we have some to look at, you know, some results going forward on what has been discussed here. Maybe 2 months is premature, but I think we should action a follow-up in addition to the idea around the adopter program. Otherwise, it'll be a missed opportunity, I think, and we'll just go off and do our own things. Whereas we need to make it our duty to follow this up and see where it goes. This is something Trust has to do within the remit of Ask Future, so we can certainly take the responsibility for that. But I agree, maybe if we also have something formally organized, it forces us to do it, doesn't it?
Mm-hmm, yeah. You know, one vector is to look, for example, for sites in common. If there are sites that they are already in the CS3 community and they are part of already of one of the S3s, that's a very natural connector, let's say. And this is one way of expanding the network, and the other way of expanding the network is through the user communities. So essentially, if we have, if we have some user communities in ScienceMesh that are also in some other sites that are not part of that infrastructure, that's also another natural route.
But okay, I mean, I know we can't discuss this now, but how do we get access to these, to those on these other sites?
Yeah, I think we'll need to perhaps have a look and get an overview of these different communities that are present on the current sites, and starting from that list, we can essentially engage and try to understand.
Okay.
Okay, so any other comments or wise words? Thank you very much for this very long day. Thank you, and thank you to the organizers, thank you to the participants, and thank you to all the contributors and the speakers, and I wish you a very pleasant evening, and we will stay in touch, right?
Thank you. Bye.
Bye.
Bye.